Hello, this is Mr. Cox with Supercharged Intercooled Science. Today we're going to talk a little bit about resonance. I have some tuning forks here. Notice this tuning fork. These tuning forks were originally made for the purpose of calibrating scientific equipment and for tuning musical instruments like pianos, string by string. This is 256 hertz. That's the frequency, how many waves go by in a minute. And that is middle C on a piano for those of you who are musicians. So you always want to use a rubber mallet when striking these. See if you can hear the waves. When you point it at you, I don't know if I picked it up on the video or not, but and then pull it away, you can kind of get the Doppler effect, kind of like if a train's coming towards you, the horn and on it and the sound of it will sound different than when it's going right in front of you, and it'll sound different when it's going away from you. This is the Doppler effect. So this is a C. Now, these have been used a lot lately for alternative medicine and new age kind of stuff. There's no science behind that, by the way. I'm not knocking anyone's beliefs or anything like that, but tuning forks were never made for that type of thing. They're for musical instruments, for tuning them, and for scientific instruments. So we can't find the actual frequency that a person vibrates at. And by the way, that would change a little bit moment per moment. All of your cells and every parts of your body would have a different frequency they're vibrating with, and it would make a little difference to whether you're running, sitting still, excited, depressed, whatever you're doing. So you can't really take a tuning fork and tune somebody, by the way. Now, resonance is a really cool thing. That's where one vibrating object, the frequency of sound that is putting off, or the frequency of the mechanical waves come off of it, can either increase the frequency of waves or support those being something vibrating the same frequency, or they can actually start something vibrating that wasn't vibrating at the same frequency if the structure is made to occur at the same frequency. I ordered some of these from Walmart. They're actually carry these now. These are nice little sound boxes that amplify the sounds of these tuning forks naturally. There's no electronics to them. It's just the wood naturally amplifies it and sends the sound out. Notice the sound will be coming out mostly from the opening in the wood. These two tuning forks are the same type, the same size, the same material, and vibrate at the same frequency. So in resonance, let me see if I can set these up so you can see them both. You can separate them from a good ways and do the same thing, but I'm going to get them close so you can see in the video. If I take the mallet, this one to the right is not vibrating at all. I'm not doing anything with it. I'm going to strike the one to the left. I struck it a little hard, didn't I? Let me hold this and then let loose of it. I can hear it. What you'll actually get then is this one that I didn't strike will start vibrating as well, because the sound waves propagated with the tuning fork I'm striking, they're amplified in this box. They'll do the same thing without the amplification boxes. It's just a lot easier to see it and hear it. The amplification boxes. This one is vibrating. Now I can do the same thing over here. When this one stops vibrating, I'll damp it there. I'm going to strike this one. I don't know if you can hear it, but the other one starts vibrating. If I reach over there, I can feel it vibrating. So that's resonance. I'll catch you in another video another day. I'll get out a guitar and show you how resonance works with it, and maybe we would look at harmonics a little bit. So this is Mr. Cox with Supercharged and Intercooled Science.